Right, year 13. I'm going to go through this question from the book. I've forgotten what bloody page it is. It's question 9 on page 286. So here we go. A patch of oil pollution in the sea is approximately circular in shape. When first seen, its radius was 100 meters and was increasing at a rate of 0.5 meters per minute. At a time t minutes later, its radius is r. An expert believes that if the patch is untreated, its radius will increase at a rate which is proportional to 1 over r squared. I've written all that important information there. Write down a differential equation for this situation using a constant of proportionality k. So the radius increases at a rate that's proportional to 1 over r squared. So that looks like that. And then that becomes that differential equation. Find k using the initial conditions. Well, you're told when t is 0, that rate is 0.5. So I'm going to substitute 0.5 in there. And, well, I can't put t as 0 into that. I need an r value, but there is one up there. So if we substitute in that and that into here, boom, we'll get k. So k is a half lots of 100 squared, which is 5,000. Excellent. Hence calculate a prediction for the radius after 2 hours. So I'm going to write this into my differential equation. Now, in order to get a prediction for the radius after 2 hours, I'm going to need to solve this differential equation. So we're going to need to separate the variables. That's how I would separate them. Times the r squared up in front of the dr and multiply the dt up after the 5,000. Now we integrate both sides. Like that. And then I'm going to times through by 3. Oops, that's supposed to be r cubed. Not much space here, but you know. Right, I've got this mystery c, or 3c as I've written it, because that c had to be times by 3. Some of you will know you can just leave that as a c, which is a bit cheeky, but I'm being a good boy. I'll leave it as 3c. Now we can work out that c using those initial conditions. When t is 0, r is 100. So sub those into here. 100 cubed is 15,000 times 0, which is nothing. So 3c is 100 cubed. I don't actually need to work out 1c because I can replace all of that there with 100 cubed. So this is the particular solution of the differential equation right there. And I've got to put in 2 hours. Now I have to be a bit careful here because the time in the question was in minutes. So I'm not going to put 2 in, I'm going to put 120 in. When t equals 120, r cubed equals, well, I'm going to calculate it. quite a big number. I'm going to go standard form. And I need to cube root that. $140.9 meters. Now, does that sound sensible for a patch of oil pollution in the sea? Being an expert on the matter, I'd say yes. Right. Revised model with treatment. Radius increases proportional to that. New differential equation. Right. Let's do this on a separate piece of paper, because this might be a bit more tricky. Same initial conditions. So, here we go. I'm separating the variables. I'm doing that before I've written the equation. Silly boy. That's better. Ooh, I've got to work out my new K as well. So the initial conditions are that is a half when T is 0 and R is 100. Squared times 2. 100 squared is 10,000. But that 2 is going to disappear because I'll times that 2 over there to be 1. So K is 100 squared. A different value to what it was before. So there's my differential equation, which I'm now going to solve. Just having a look at the question. Oh, that's done part 3. I'm doing part 4 now, which wants me to solve it and shove in 2 hours again. So I'm going to separate the variables. Like that, and try and integrate both sides. The left side's nice and simple. The right hand side, it's going to be a ln because I've got 2 plus t. I'm going to put the 100 squared out the front. I'm going to turn that denominator around. And the top is the derivative of the bottom. So it's 100 squared ln of t plus 2. And then I need plus c. Okay. Got to times through by 3. 100 squared is 10,000. So we'll have 30,000. There we go. Now we've got to suss out what C or 3C is. Now the initial conditions are R is 100 when T is 0. So substitute all of that in. 100 cubed is 1,000,000. Yep. I'm not going to work that out as a decimal. I'm just going to, oops, not one the over 3. I'm rewriting this line here, replacing the 3C with that. At least that's what I'm trying to do. Ugh. And I've got to get an estimate for the radius when t is 2 hours. So I'm going to do this on my calculator and then cube root it. Well, I've no idea if that's correct, but it's a similar sized answer to the previous one, and it is modelling the patch being treated with chemicals. So you'd imagine the patch will be a bit lower than what it was with the first one when it was untreated. Hopefully those are correct. I can't be bothered to check them now. I will do once the video's over.